Okay. Okay, so let's get started. Yeah, please can whoever has the mic on, mute it. Okay, Kleber, do you want to say some introductory thing before we start, or should we?
Yes, can everyone hear me?
Yes.
Yeah, so for the ones who don't know me already, I'm Kinyarwanda. I'll be assisting Antoine, and while we go through the trainings and even the software, the open source software, you can engage with me in case you need any help with the tools that we are going to provide. And yeah, basically that's it. Thank you.
All right. Thank you, Kleber. My name is Antoine Nzeimana. Currently, I'm a PhD student at the University of Massachusetts in Amherst. It's in the United States. And so I also have an independent research and development project through a team called the Kinyarwanda. And today I'm going specifically to talk about Kinyarwanda natural language processing. More specifically, I'll be talking about the development of the morphological analyzer and generator that I have worked on for the past several years. So the title is Building a Morphological Analyzer and the Generator for Kinyarwanda. So because it's about morphology, I will also introduce to the subject called computational morphology, which is a set of techniques, or rather an area of study that tries to apply computational science to the study of language morphology. I'll be using some of the slides from Professor Kemal Oflazer, who is a professor at Carnegie Mellon University in Qatar. I think he's the world expert in computational morphology, so I'm going to start presenting some of his slides, which talk more generally about computational morphology. And then in the second part, I'll be talking about the morphological analyzer and the generator that I have worked on, which is going to have three topics mainly. So there's morphological analysis, which is basically performing analysis of the morphology of the words. This is specifically for Kinyarwanda. Then I'll talk about the problem of morphological ambiguity and morphological disambiguation, try to make the analysis more accurate. And then I'll briefly talk about the components of morphological generation, which is about when you have morphological information and you want to generate the word that you see. That's a normal word that someone has, that's usually written. We talk about this morphological generation. Then I'll conclude by doing more practical presentation about the software tools that we have released, the ones that Kleber was talking about. So let's get started and talk about computational morphology. Excuse me. So these are slides that were released by Professor Kemal Oflazer, and it provides a high-level introduction to the subject of computational morphology. So when we talk about morphology, we are talking about the structure of words. So in language, when we are talking, when we are writing, we typically use words. But in many languages, the words have a structure in them. And the structure can be made of several units of meaning or several units that give some information about the word or the role of the word in a sentence. And so the structure or the components of an individual word, they can also specify the type of word it is. So if it's a verb, if it's a pronoun, the structure of the word, the information that's contained in the word will give you these categories, and also give you the function that the word plays in a given sentence. And I think many people, I mean, at least in high school, we all study languages. We study foreign languages and we learn different things. But we know that in words, we know sometimes they are nouns, they are verb, they are pronoun, and so on. And so each of those, depending on the language, might have a different structure that conveys the information for the word. And so different languages have different kind of morphologies. So language is basically a natural phenomenon that sometimes develops independently because of different geographical locations. So every language has a history, and it's a natural system that is developed by the speakers of the language. And many languages have developed independently, although some are related. So that's why the type of morphological phenomena you observe in the languages is going to differ depending on where the language comes from or the evolution of that language through history. So this is an example of the structure of the word in a sentence, like I am swimming. So when you analyze this word, you can see three parts. So there is swim, which gives the basic meaning of the whole word, like it's the main semantic unit that gives the meaning to the word. But you also have two other components. You have the M in the middle, you have the ing at the end. So beyond this, the root swim, you need to have these other parts of the word to give you the information that you need. So the ing at the end means that it's a continuous present time. So meaning the person saying I'm swimming, he's saying it right now. So the time they spell this word, this sentence, they are doing the activity of swimming. So that's what the ing at the end does. The extra M in the middle is somewhat mysterious. It doesn't really have a semantic meaning. It only has a conventional orthographic meaning. So it's something that the people who use the language, they ended up adding that M in between. And so when you do the morphological analysis, you have to as well uncover these other pieces that probably don't have a lot of semantic meaning, but they have orthographic meaning, meaning that when the word is written, you have to add that M in between. So another thing about morphology and words is, why do we care about studying words or the structures of words? So in natural language processing, you need to care about words because, of course, we know what words are. The meaning of the words is in the structure of the words. And so if we need to do some analysis of language data, and it's a language that has complex words, so words that have a complex structure, complex morphology, you need to uncover this structure and the elements of the word. So so in different applications for certain languages, you need to do this pre-processing of uncovering the parts that make up the word to be able to get the meaning or the structure of the sentence at the end. So there are many other applications, as you can see. So if you are developing a tool for spell checking or spelling correction, you need to know what the valid words are, and you need to know if you are correcting the misspellings of something. You also need to know which other words that are close to it, so you can propose them as substitution. And so for all of these applications, you need to know what is a valid word in a given language. In English, it's kind of easier because English doesn't have a very complex morphology. For the people who have studied like French, you know, conjugaison, you have to know how to make the agreements as you make a phrase in French. Or in other complex morphology languages like Turkish, you need to know the rules for making valid words, which is typically different from English, because English doesn't have a very complex morphology as compared to other languages. So there are many other applications. If you are doing grammar checking, you need to know the agreement constraints between the words in a sentence. If you're doing text-to-speech, you need to know the kind of word. You need to disambiguate a word to know how to spell it out. Or in machine translation systems, you also need to know the meaning of the words and their structure and their functions. And here's an example, like if you say word read and you want to know how to use it in different sentences, you are going to know the morphology, or at least the part of speech it is, to be able to do the application. So the field of computational morphology basically has two main parts. So it's a technique for basically analyzing and synthesizing words in a computer program. So you always have these parts, these two pieces of subject in morphological studies, where you have to do the analysis, where you're given a word and you produce the analytical structure of it and the different parts that make up the word. So that's the analysis. The inverse is the synthesis, where you're given like a stem or a root of the word, and you're given, let's say in French, you're given a verb, and they ask you to give the conjugaison in a given tense. So that's the synthesis part. So for computational morphology, basically you have to extract the information that's in the word, so that once you recover those information, you can use the information you get in two different applications. And as you can see here, you can see, for example, the word books. It might be a noun, or it might be a verb in a given tense. Okay. So for the morphological generation, you are given the features of the word. So you're given it like a root, and then you're given a tense, and then you have to produce the actual spelled out word that can be used in a writing or something else. So in terms of natural language processing pipeline, the morphological analysis or morphological processing comes in as a middle layer. So at the high level, at the start, you have the pre-processing state. So you have the text. Let's say you are doing like a name entity recognition, or you are doing some task of analyzing text. So the first step, of course, is to get the raw input. And then you need to tokenize it or segment it. So basically splitting out documents or sentences or paragraphs, splitting them into words. So that's the preprocessing, which is the tokenization or segmentation. And then at the next level, you have to do the analysis of individual words. So you parse the words, especially when they have a complex morphology, and then you get the components, and then you need, because of the ambiguity that might result in the analysis, you need to do disambiguation. After you pass that step, then you can go to further processing steps, like doing syntactical analysis, which is basically analyzing the relationship between words in a sentence. And then you can go to other levels where, for example, if you're doing an application for information extraction, you can use the syntactical information, which is based on the morphological information, to do the high level task that you're doing. So when we talk about morphology, we are basically talking about the structure of words, and we need to take we need to make note of some terminologies that are used there. So the smallest units that you can find in a word, they are called morphemes. So morphemes are basically the units that make the morphology of the word. And morphemes themselves might be made out of phonemes. So phonemes, I think these are the pronunciation of the different pieces of information you have in the morphemes. And then you end up going down and getting symbols which are basically like characters. So there are two types of morphemes. They are the so-called free morphemes, which basically are morphemes that don't have anything else attached to them. So you have a verb like go, it's a morpheme. It doesn't have any prefix, doesn't have any affix. So you just have it as a single morpheme, so a single word. So these are called free morphemes because they haven't anything attached to them. But you also have bound morphemes, which are morphemes that can be attached to other morphemes to complete the morphological function. So for example, if you have the word go, you can add ing to say going, or book, you do booking. So these other morphemes, the ing, the s, the plus ness, these are bound morphemes because they need to be attached to the stems to make a meaning. And so there are some aspects of computational morphology that someone should be aware of, at least the different topics around morphology. So one is the complexity of words. So how many morphemes do you have in a word? It depends on the language and depends on the type of word you're talking about. And then the other question you need to see is what function do the morphemes convey? Do they convey a tense in a verb? Are they conveying information about gender or other functional utilities in language? And also, how do the morphemes get together? So these questions are addressed in computational morphology, and we will talk about more as we go forward. So in terms of the complexity of the morphology, there is some kind of classification of languages. Personally, I don't like the classification because sometimes they are not like perfect. So, but it gives like a typology of different languages in terms of the complexity of their morphology. So they are so-called isolating languages, which typically don't have any bound morphemes. So everything is a word. It's a single word that doesn't need morphemes to make to make grammatical relationships. So for example, here they have Mandarin Chinese, the Chinese. So you have like this word, I don't know how to pronounce it. So go bu ai chi inside. So each Chinese character, it's a semantic unit on its own, and they don't need any bound morphemes to make meaning. But this causes some ambiguity when you are seeing it. It can mean several things. So, for example, this word, it can either mean the dog doesn't like to eat vegetables, the dog didn't like to eat vegetables. So there's nothing that differentiates the tense of this word chi. So it can mean it doesn't eat or it didn't eat, and so on. So there's ambiguity, but when you are talking to a person and you are looking at this sentence in a given context, you can understand what it means by essentially doing disambiguation by looking at the context. So those were isolating languages that don't have bound morphemes in them. So the other big category, I think, of many languages in the world, these are inflectional languages. So these are languages where you have like a single morpheme to convey the morphological structure of the word, like to give you the function of the word in a sentence. So for example, in this word, I guess it's Russian. So Professor Kemal put in parentheses the type of language it is. So this, I think it might be Russian, but I may be wrong. So you have like this root, you add a single morpheme and you get a different meaning. You get a different role of the word. Or in this, I guess this is Spanish. You have like this word habla, and then you add the mos, and then this can convey the meaning of the word in the sentence. I mean, the function of the word in the sentence. So they typically have like a single morpheme, a prefix or an affix to give the meaning, the function of the word in the sentence. So the other large category is the so-called agglutinative languages, which Kinyarwanda is part of. These ones, they typically have a lot of bound morphemes in them. So for example, this word in Turkish, I think Professor Kemal worked a lot on the Turkish language in his morphological studies. And so many examples are given in Turkish because Turkish is a very morphologically rich language. So you have a root, and then you have to add a bunch of affixes, a bunch of bound morphemes to give the meaning. And each piece of morpheme is going to give some linguistic information about the role of the word. So the root gives the semantic information, like the meaning, the basic meaning of the word. And then these other morphemes are going to convey the function or some other piece of linguistic information for the given word. And some language can go to an extreme point like this Finnish. I don't know how to read it, but basically they can have this whole word by adding so many. So you have the root and then you add so many bound morphemes to make a final word. Crazy. It's like a sentence by in a single word. So languages are very different in this case. And Kinyarwanda is basically among the agglutinative languages because when you speak, when we speak Kinyarwanda, sometimes we add more morphemes to make the meaning of the words, especially for verbs. But we're going to talk about those ones. We're going to talk about Kinyarwanda specifically later. So these are other examples of languages that are agglutinative. So you have a lot of so you have a lot of morphemes that are added to the roots to make different meaning. I think at this point we understand a little bit more about this concept of morphology because in Kinyarwanda, when you're learning Kinyarwanda, morphemes are called uture majambo, which means the parts that make up the words. Yeah, so these are other examples of morphologically rich languages like Finnish, which still has to combine a lot of morphemes to give a meaning. Unfortunately, I didn't get the English meaning of this one, but it's kind of the same process. We can skip these. So closer to home, here, Swahili. Swahili is closely related to Kinyarwanda because they are all Bantu languages. And so the verbs of Bantu languages, like Kinyarwanda, they are very complex. I'm going to show a table of the different morphemes that make up verbs. So it's another morphologically rich language where when you give me a verb, it can give you the information about the tense, information about the subject and the object, and so on. Then there are other languages that are called polysynthetic languages. So these are languages that can group together multiple words. So it's not a single word, but it's also considered as morphology. So for example, this is the Eskimo language I don't know how to pronounce it, Inuktitut. You have a single word that expresses a whole phrase. So like, okay, so this is the same example of polysynthetic languages. And then there are some languages that are in between. So the reason I said I don't like classifications and classifying things is natural things is sometimes the classes, the groups don't themselves have very clear boundaries. So you might find a language like Arabic, which has aspects of the different categories we talked about. So it has aspects of inflectional language. It has aspects of agglutinative language, combining so many morphemes. And also, it also has aspects of polysynthetic languages. So both phenomena can be observed in the same language. So these classes are just ways of thinking about the complexity of the morphology, but languages can have aspects of both categories. So then we talk about the morphological processes. So morphological processes basically is the roles that the morphology plays in the language. So there are three types of processes. So one is the inflectional morphology. So this is basically transforming. So by adding morpheme, by putting together morphemes, you are trying to replace the same word with the same meaning, but with a different function in the sentence. That's inflection morphology. The reversional morphology, you take a word and you convert it into a different word that is a different type of word, that's a different part of speech. And then the compounding is when you add them together to form other words. So we're going to see examples more here. So inflectional morphology basically allows a word to change the form, but staying in the same inflectional group. So if it's a verb, for example, you have a verb in French, manger, and so when you conjugate it, it still talks about manger, eating, but it gives a different conjugation, it gives a different function in the sentence, like making some arguments with the subject and gender and so on. But it's still basically about the word man. It's still in the same root. So that's inflection. That's so you change the word to make agreements with the other parts of the word in the sentence, but you still have the same part of speech. So that's inflection. So here is some examples. I'm not sure what these languages, maybe German or something. But basically, you still have the same thing. So, for example, this word in this language that Professor has indicated, it gives, so it means it's about a house, but you can make different types of determination about the house. So it might mean to the house, or it might mean the house, or it might mean at the house, and so on. So it's just giving different functions to the word, but the word is still based on house. So, for example, in Kinyarwanda and other Bantu languages, you might have this thing called noun classes, which are basically a way of classifying the things in Bantu languages. So, for example, in Kinyarwanda, you have umuntu, and then you say abantu, or in Swahili, mtu, and then watu. Just to make, it's still about umuntu, but it's going to make it plural and so on. So these kind of changes are inflections. So the word stays in the same part of speech, same meaning, but it has some other information attached to it, like the number of objects you're talking about, and so on. Or indicating gender in case of European languages and so on. I think you can skip this. This is still about the different functions that can be added to words in Arabic. And so it's like the French conjugation I was talking about. So derivational morphology is another process of morphology where basically when you do a derivation, you change the part of speech, you change the inflection group, and it means something else. So for example, in Kinyarwanda, you have a verb kugenda, which means walking, and then you have a derivation called umugenzi. So that process of having something based on kugenda, and then you make some other word of a different part of speech, umugenzi, kugenda, umugenzi, that's what we call derivation. So there's difference between derivation and inflection. That's a difference. So you change the part of speech. Okay, or you have this example in English, you have happy, which is an adjective, and in happiness, it's based on happy, but it's a different part of speech. So it was adjective, then you make a noun out of it. So this is derivation. And there are two types of derivational morphology. There's a productive morphology where the type of rules you follow to make up new words apply to almost all members of the part of speech, all of the members of the group of words you're talking about. And then there's unproductive. So I think in Kinyarwanda, it's mostly unproductive because, for example, if you take that example of kugenda, umugenzi, it doesn't apply to all verbs. I mean, it might apply to many verbs, but you cannot have that process on any type of word you have. For example, okay, you might have a verb like kurya, and then you do umurgi. But if you have a verb like, let's say kwichara, to sit, I don't think you have a word for someone who is sitting. So this is unproductive. So it doesn't apply to all verbs. It applies to some of them like kurya, umurgi, kugenda, umugenzi, but it doesn't apply to it doesn't apply to other verbs. So this is unproductive. So the other class of language, the other class of morphological process is compounding, which is basically getting two words and putting them together. For example, you have fire and you have fighter, and then you have firefighter. So it's a completely new word, but it's just putting together two words, fire and fighter. So this is what is called compounding. And the other process we talk about in morphology is how do morphemes come together. So there are different types of morpheme combinations. So the simplest one is concatenation. So you have happy, you make the word happiness by adding ness. So these are processes like adding prefixes or suffixes to words. So these are just simple concatenation. Trying to go faster. Okay. So when you do concatenation, it's not just putting two strings together. When you're adding morphemes to a word, or when you're making words to make morphemes, you might make some changes to the original strings to meet the grammatical conventions of the language. So, for example, the word happy, it ends with a Y. But when you want to say happiness, when you want to do this derivation, you change the Y into an I. Same thing in many languages. Even in Kinyarwanda, I'll give some examples. So that's where morphology becomes interesting in a way, because in natural language processing these days, when people are analyzing words or when people are doing tokenization, they split words with one algorithm called byte pair encoding, or BPE. But when they split, they don't recover the original word. So if they process a word like happiness, they will produce happy with the I and an S, but they will not recover the Y that was supposed to be there for the original word. So you might end up having happy with I and happy with I being two different tokens. And so when you're processing them for example, when you're processing those tokens, usually they should be the same. They should map to the same thing, linguistically speaking. They should map to happy with the Y or whichever representation you want. But when you process them based on what you see, based on the string you see of the word happiness, the word happy, the part of happy becomes two pieces, becomes two different tokens. But if you're doing it linguistically, you will be mapping it to the same word. So that's something to consider. So this is concatenative combination. So the other kind of morpheme combination you have is the infixation. So infixation, you take a morpheme or what's called an infix, you put it in between the two words. So for example, in this, I'm not sure what this language is. You have this word ficus, and then you split it and you add the UM in between. So from ficus, you get fumicus. So this morpheme is just added in between, and it's called an infix. So it's infixation. There's another interesting one, which is called circumfixation, where you have the word like, let me see. So you have this word in German saying Sergeant, and then you have this process where you preserve the sag, which is the root, and then you add the morphemes around it. So this is what they call circumfixation. It's another kind of morpheme combination process. And then you have languages like Arabic. I think I heard that Arabic, like when you have the word written, you don't have the vowels, but when you're going to speak to, when you're going to conjugate it, you have to fill in some vowels according to a given pattern. So you have a template: consonant, vowel, consonant, consonant, vowel, consonant, and so you spread it out and you make sure that it matches this kind of template. So this is what they call templatic combination. So I think they give more examples here. So when you are conjugating or expressing words in Arabic, you have to fill in these patterns, and then it gets a sense. But initially the root doesn't. So the root KTB, I'm not sure if it means reading or something. so you have to take a root, you add a template, and then you add the vowels, and then you get the full word. I have no idea how Arabic works, but I guess from here, this is a very specific way of generating morphological inflections of the words from matching a root to a template. The other process is called reduplication. This is a process that's also happening in Kinyarwanda, where you have a repetition of some morphemes. So, for example, you might have a verb like kugenda, and when you're going to conjugate it, you might say someone aragenda genda, or kuvuga aravuga vuga. So you have this repetition of the morpheme, specifically the stem in Kinyarwanda verbs. So it's called reduplication. So you duplicate some of the morphemes to express something. So in Kinyarwanda, reduplication of verbs usually means kind of repetition of something. So if you say umuhari kugenda, someone is walking around, and then you say aragenda genda, you mean he's repetitively doing the same thing. So this is reduplication. It's kind of gives a pictorial interpretation of the action you're seeing. So reduplication basically is a repetition of morphemes to express things like a repetition in Kinyarwanda. And then you have derivational or inflectional zero morphology. This is where no morphemes added or removed. It just becomes, you just have the word mean something else. So this is an example of English. You might mean a second, meaning the second thing, and then you change it to second, which means to be the next something. Or you have a noun like a man, and then you make it a verb to man something. So this is a morphological process that does not involve any change to the spelling or to the structure of to the word as you see it. So it gets a different meaning without any morphological, any apparent change to the actual word. So then there is subtractive morphology, where then some things are removed. So morphemes are removed. So this is an example of some of the language where you have a word and then you remove it. Although to me, I think it looks like the reverse of infixation, but I think the longer word is the root, so it is like the lemma, the main part of the word. So when you go to this process, it's called subtractive morphology. Okay, so now we're going to talk back again about the computational. So the things we were talking about were mostly linguistic. Now we're going to talk about the computational aspect of them. So as we said before, there are two types. There are two processes in computational morphology. One is the analysis. You're given a word, and then you give out its features and it's part of speech. And then there's synthesis. You're given a root and then some features. So features means like either morphemes, or if it's a verb, maybe the tense and the subject indicator and things like that. So you're given it's the reverse of the analysis. So I think there's a picture here. So the morphological analyzer, which is a piece of software or a computational engine that processes words, you give it a word like ndagenda, and then it's going to process it and gives you the pieces of information about it. So it's going to say it's coming from the verb kugenda. It has a subject, which is me, and the tense. So you give it the word, it gives you the roots as well as the features of the word. So this was the example. So you have the word like stopping, you analyze it with the morphological analyzer, you get this the stem being stopped, and then you get the information that it is a verb and it's in a present continuous time. So this is what morphological analysis. So ideally, we would want to do the same thing in a reverse, whereby you are given these features, you are given a root and the features, and then you generate the word. So this is what is called the morphological generation. It's the reverse of the analysis. So, but the question that we're going to talk more about in terms of Kinyarwanda is what's in the box? What do you do? How does the box work? So this is something that has been studied before. And so basically inside the morphological analyzer, there are two pieces. There is data and engine. So the data gives the rules and the list of words and the linguistic information about the language. And then the engine can be an algorithm that is language independent, that given the words, it looks at the rules, and then it produces the analysis, or you give it analysis or roots and features. It looks at what the rules say, and then it gives you the words. In my case, so my view is actually that the data can also be split into two pieces. So there are rules, and there are also data in terms of, so what's the difference between the data and the rule? A rule is, of course, a pieces of data, but the rule expresses, I think the rule expresses some kind of process. A rule expresses a process. The data might mean something like examples of words or examples of parties. So that's why my view is that actually the engine is made up of three pieces: the engine, which is the language independent algorithms, and then the rules, which are specific to the language, and also a data set, a list of examples of rules, examples of words and the analysis that can be used in this case. So the question is, how do you develop this thing? Clearly, you need both components. You need the engine, you need the data, and you need the rules. And in terms, so here is a terminology of the things that you need in terms of data and rules. So one is the lexicon. So the lexicon means the list of root words. So if you want to develop a morphology for Swahili, you need to have like a dictionary with okay. So excuse me, I'm not monitoring the chat, but you can exchange information, or you can pose and ask questions. So the things you need a lexicon. So lexicon is basically like a dictionary. So you have the list of words that you can look at, and the list of morphemes. So you need to have, so I was saying, if you want to do like a morphological analyzer for Swahili, you need to know all of the words, all of the root words in Swahili. I need to know all the morphemes that are used in Swahili for those words. So that's the lexicon. Then there is so-called morphotactics. How do you combine morphemes? How do morphemes come together to form words? So that's called morphotactics. And the last one is morphographemics. So in this word morphographemics, if you do morphological analysis of this word, you see morpho, which is one piece, then graphemics, which kind of graphs or graphemes. So what this means is the changes that happen to the string of words that when you do morphological synthesis or when you do morphological analysis, the changes that happen. I'll give you an example. So if you have a derivation, the example I had given umugenzi. So the root is kugenda or gend, that part of it. But when you add like a y at the end, it doesn't say umuyendi because dy is not like a valid complex consonant in Kinyarwanda. So you have to make that d plus y become z. And so this is what morphographemics. I think in Kinyarwanda, when we were learning Kinyarwanda in high school, in secondary school, we used to call it amategeko y'igenamajwi. So for the people who speak Kinyarwanda, I guess most of you that do, you have like you had like the analysis of word, let's say umwana. So you have u plus mu plus ana, but when you say mu and you add it to ana, you have to make a w to make up the rule. So that's a morphographemic change that tries to adapt to adapt the semantic pieces of information to become the strings that you see at the output. Okay, again, the data that is needed, you need the lexicon, which is a list of words and a list of morphemes that are allowed in the language. You need to know the morphotactics, how do morphemes combine, which combinations are allowed. In Kinyarwanda, we'll talk about this specifically for Kinyarwanda, but it was important that we touch this subject because when you go to the second part and we do Kinyarwanda, we're going to fill in the gaps here. So what are the morphotactics in Kinyarwanda? We see what they are in Kinyarwanda. So, but it's important to know these topics. So morphotactics, how the morphemes combine. So these are examples in Arabic and German. I'll give you examples in Kinyarwanda, but so it's still about the same process of affixation, infix, circumfixation, and prefix and suffixes. But there are rules on which morphemes can be combined to make a word. So so that is what is expressed by the morphotactics. And then the morphographemics is the changes that happen when you have the morphological structure of the word and you put together the morphemes and you need to form a final string. So those are morphographemic, the changes to the graphemic, the changes to the output strings that you get. And there are two concepts in terms of morphographemics So one is called lexical form and the other is called the surface form. So the lexical form is the list of the parts that make up the word. So for example, if you have something like easiest, you have easy and est, and this is like a lexical representation of the word. Lexical meaning you show the parts of the lexicon that form up the word. So you have two morphemes, easy and est. This is the root, which is in this case a free morpheme. And then you have est, which is a bound morpheme. And so when you put them together, like in this representation, this is the lexical form. We present the parts of the lexicon that form up the words. While the surface form is the actual output string. So usually when you are doing morphological analysis and synthesis, you are going through these two forms. So you are coming from the lexical form to the surface form. This is the synthesis. We are coming from the surface form to the lexical form, which is the analysis part. Okay. And then you also need a bunch of things like a list of words and to test coverage and so on. The other process in morphological analysis that you need to care about is the morphological ambiguity. So when you're analyzing a word, it might mean different things depending on the context. And this is where the ambiguity comes on. So for example, here you have a word book, which can mean a verb like to book a hotel room, or a book, which means a book to read. So although they are the same, they look the same outside, but when you do the analysis in the context, you need to classify them in two different groups. So which is their morphology. So this is an ambiguity that you need to disambiguate if you want to do the analysis of the word. So you have the same thing with this French word dance. yeah, so morphological ambiguity is a big problem when you're developing a morphological analyzer, and so you need to resolve this ambiguity by doing some techniques that I'll talk about on the other side. So morphological disambiguation is the process of choosing the proper morphological interpretation of a token in a given context. Here you have an example. He can, they can. So you have this can, which is a model. It's a linguistic, I think it's a linguistic category. And then you have he can, it's an infinitive verb. And then you also have the can at the end, which is a noun. So when you are interpreting this sentence, you have to map each of them to a specific morphological interpretation. So this is the disambiguation process. And the techniques to do them, so typically these days, they are based on statistics, probabilistic models, and things like that. So they're usually, so morphological disambiguation is typically done by doing some statistical modeling or machine learning. And for example, in English, disambiguation is very easy because English doesn't have a complex morphology. So you get accuracies like 97, 98% for English. But for other languages, it's much lower because of the complex morphology and more ambiguity in those languages. Okay. Also implementation. So we talk about the implementation of doing computational morphology. There are three ways of doing it, which can be combined. So implementation can be based on a database. So, but this is less applicable. So you have a database of words and their morphological analysis. So when you're analyzing, you just do a lookup. You have a lookup table, look up the words, you get the analysis, and you're done. So, but this is less practical because it requires to, I mean, in some languages with simple morphology, it's possible to have parses of all words in a database or in a data set. But in morphologically rich languages that have complex morphology, this is different. You need to have a productive way. You need to have an analyzer, not a lookup table. So okay. So there are two main ways of doing it. There's what's called heuristic or rule-based, where you have a very language-specific analyzer that is following some rules of the language to do the morphological analysis and synthesis. This is what I have done for Kinyarwanda because of the complex morphology. There are other methods called finite state approaches, which are more generic, but also produce more ambiguity. It's a very, so finite state morphology is another big branch of morphology, computational morphology. And so many applications typically use finite state tools. I think that there's a tool called Xerox tools that are based on this generic approach. But as I said, it's generic, but it can produce a lot of ambiguities, and you need to deal with that. The other one is the rule-based. It's kind of hard because you need to develop the heuristics, but it's more accurate. It produces less ambiguous analysis than the finite state tools. Okay, I think we talked about this, so we can skip to go further. So finite state morphology is a very big topic in computational morphology. I'm not talking about it because of the time limitations, and that the morphological analysis I have is not based on finite state tools exactly. It uses some elements of it, but it's not using the generic tools. So so I'm not talking about it. So let's take a break. Some people can ask questions in the meantime. The next part is going to be very specific for Kinyarwanda, and it's more brief. So it's kind of applying what we saw in these slides from Professor Kemal to Kinyarwanda and showing how different pieces of theories or different pieces of topics we covered in this part, how they apply to Kinyarwanda, and we get more examples of Kinyarwanda. So let's take a break for, I don't know, 5 minutes, and then we can resume the second part where we talk about Kinyarwanda morphological analysis and generation. In the meantime, if someone has questions, you can ask before we go to the next part. Any questions? Oh, let me see the chat. Thank you. Okay, a question from Flavie. Okay. Okay, so one question from Flavien. Which methods used to know all the words of language like Kinyarwanda the typing in the database? So how do you know the type of words? I mean, how do you know the list of words? So the simplest case is to, so basically the lexicon. So the simplest way is to have a dictionary. So if someone has compiled a dictionary, you can get the list of words from there. But because of the complex morphology and the morphological generations that happen in a language like Kinyarwanda, you need to, you can't have all words or all words that exist in the language. So another way of doing it is getting a corpus. Like, let's say you get data from newspapers or books, and then you extract all of these words. So a dictionary or data from like the web, and you get a list of strings. Of course, when you get data from the web, how do you differentiate words that are Kinyarwanda from those that are not? One way is to have, okay, one nice thing about Kinyarwanda is that Kinyarwanda has a very specific orthography, which is, so Kinyarwanda words typically have what's called open syllabs, where the jambo ry'Ikinyarwanda, they end with a vowel. I mean, it's not the word. So okay, I'm going to say it in Kinyarwanda. Kinyarwanda, we have ibihekane n'ingombajwi n'inyajwi. So every consonant or every consonant cluster, it usually ends with a vowel. Donc, buri syllabe Kinyarwanda iherwa na vowel. So if you can develop a tool that can recognize that pattern, uzi liste y'ibihekane na liste y'inyajwi na liste y'izisanzwe, you can follow that structure, that orthography to know at least that a word is in Kinyarwanda. So one way to do it is so one is the function to know the orthography, and then the other is to know the number of, sorry, the ratio of words that match that orthography. And one simple way I do is, so first I recognize the orthography, that it's using open syllabs and using Kinyarwanda consonants and consonant clusters. And then and then I count. So if I get like an article, let's say you get an article from a newspaper, egh.com, and you follow that algorithm, you see that words with the open syllabus is greater than 50. It's usually greater than 70%. So if you have 70% of the words meeting the orthography, you can say, okay, this article is probably in Kinyarwanda. And then if you go to another website, let's say the New Times, where they publish in English, when you go there, you start seeing these syllabus that are not open. You start seeing X's and Q's that are not typical in Kinyarwanda. And when you compute the ratio of valid orthography, you're going to get something like 30% or 40%. So in that case, you can easily do that and say that this is typical Kinyarwanda, this is typical English. So so that's one way. How does one know when disambiguation work? So how does one know? So disambiguation is a big problem, and we're going to talk about two techniques to disambiguate in Kinyarwanda. Basically, as we said, that it's typically based on statistical approaches, machine learning approaches. You basically need to have a data set that you can refer to it, and if you're doing a machine learning approach, you can assess the accuracy on the test set. But basically, you have examples of words with their morphology or some piece of information about morphology, and then you can count the accuracy numbers. Okay, so is disambiguation based on word structure? Yeah, so disambiguation means, so you have an analysis, you have the word like okay, I'll give examples more in the following section, but it's so when you have the analysis, so if you go back to the okay, so if you go back to this example of the relationship between the lexical form and the surface form, when you process one word, it's kind of hard to capture that in English, but we're gonna see it in Kinyarwanda. So when you have a word like easiest and you parse it into its constituents, you'll get multiple versions. So what you have in the disambiguation is that you have different analysis for the same word. And then you need to choose one of the parses to be the correct one. So that's the problem, what you're dealing with when you're doing disambiguation. Okay, one question from Flavien. For searching word in a database, you can type a single letter and see all list of words containing that letter, then choose what you want. And you can type all words to search in a database without type, or you can't find it. Which method I have to do about these things? Flavien, you are asking, oh, okay. So I think what you're talking about is more about prefix matching. So auto-completion. So there are two ways to do auto-completion. So when you have words, so there's a technique called prefix matching, and I think there's a data structure called so I hope people here are from computer science background. There is a data structure called I forgot about it, but it's the one that does prefix matching. So you type one word and then it explores a graph of words that have that prefix and gives you the list, and you can choose from those. I think I don't remember the word, but it's a special type of data structure that you can use to do prefix matching. The other one I was talking about for auto-completion is when you are given a word, like you are typing, let's say you are chatting on WhatsApp or on your smartphone. And after you type one word, you see they propose the next one. So that's auto-completion. And so that one, they typically use language models, some kind of language models to know how words are sequenced in a language. So it's basically based on what's called language modeling. So predicting the next word given the current word. And these days, it's taken to an extreme with the arrival of ChatGPT and these large language models that can actually generate a lot of they can generate a very long text by just following their language model. So that's maybe something we're going to talk about in future lectures. But basically, for that, you need these language models. But for simple things like you type a word, you type a character, and you have something of the completion of the word, that's prefix matching. And if you're interested more about it, maybe I could look out for the data structure that is used for prefix matching, and then you get what I mean. Okay, so I think now we can go to our next part. It's not going to be very long because we talked about all the theoretical part. So now we're going to talk about the practical part of implementing this morphological analyzer and generator for Kinyarwanda. But we'll talk more about morphological analysis and morphological disambiguation. So the first thing when developing a morphological analyzer, there are things that you need. And before we say that the engine, so the morphological analyzer black box, it has two things, data and algorithms. And the data can be about rules and examples. So when I developed the morphological analyzer for Kinyarwanda, these are the main pieces of data or the main pieces of information that I need to collect. I needed to have. It's something that took many years and experimentation and so on. But these are the main parts of the morphological analyzer. So you have the inflection classes, so part of speeches. So you need to know which kind of words, which kind of inflection groups are in Kinyarwanda or in another language. So you have verbs, you have nouns, adjectives, pronouns, demonstrative pronouns, possessive pronouns, and so on. So you need to know those. And for those, then you need to know, okay, so you have those inflection classes or inflection groups or part of speech. I think the technical part is part of speech. And then for those, you need to know the lexicon. You need to know which root words are there for each inflection group, for each part of speech. So which roots are there for verbs? So you need to get all of the roots of all verbs in Kinyarwanda. Takes time, takes experiments, you need to look up in the documents and so on to collect this data. And then, so those are the roots. And then you need to also find out the affixes. Affixes, these bound morphemes are easy to find because when you're testing, you keep seeing them popping up and you compile them. Then morphotactics. How do morphemes combine? So this is also, so all of these things are empirical. In my case, I had to look through empirical data and compile all of these lists. So, but when I talk about morphotactics, I'm just going to show the model of how they form. And then morphographemics, what they taught us in secondary school, so what are the changes that happen when morphemes are combined to make the surface form? Remember, the surface form is the string you get out in a normal text. Then the lexical form is the pieces of information that come together. So you need to know all of those rules. You need to compile all of those rules for all types of words, for all types of part of speeches. And this is not enough. You need to have some custom rules, some kind of filtering. So when you do the analysis, you're going to get a lot of ambiguity. And so you need to develop rules. Some of the rules are hard rules, like required. Some others are optional. So you need to have those. And optional rules are usually used for scoring. Like so if you have two rules that are conflicting, you give them two weights, and then when you do the analysis, you do it probabilistically, and those weights, those scores can help you give more value to one type of rule of the other, or give higher probability to one analysis over the other. So these are the pieces you need. So let's go into it for Kinyarwanda. Now, inflectional groups or word type. I call them word type. But so the way I develop this, I'm not a linguist. I'm a computer engineer, and I don't have a very solid linguistic background. So I'm going to talk about the terminology that I use in my morphological analyzer, but it also has some linguistic meaning to it. So I identified seven types of inflectional groups. So inflectional groups means part of speeches that can be combined, part of speeches that can be productive, so that can generate inflections. So the first one is the verb. Verb, they express different things like actions, and especially actions and so on. So that's the first category. Very complex morphology in Kinyarwanda. I have a research paper almost about the verb. And then nouns express like objects or concepts and so on. Then you have adjectives, qualitative adjectives. Kinyarwanda typically doesn't have a lot of adjectives because the role of adjectives is usually played by the verbs. So so if you want to say, let's take some adjective in Kinyarwanda. So let's say the verb, the adjective, let's say conclusive. Conclusive. You don't have a word that is an adjective in Kinyarwanda for that, but you can make a verb that expresses conclusive. Or any other adjective. So Kinyarwanda has like I don't know the number, but it's something like that's less than 100, or even less than 50. So qualitative adjectives. So another inflection groups is possessive pronouns. Possessive pronouns is things when you say like wanje, umwana wanje. So wanje, that's a possessive adjective. Then demonstrative adjectives. Uyu, uriya, wa. So those are demonstrative adjectives. Then you have numerals, or things that are expressing numbers. Rimwe, kabiri, abantu batatu, barindwi, icumi. So those are numerals. So they are also productive. So they inflect. So if you have abantu babiri, so that's an inflection of the numeral 2. Or you can say inzu ebyiri. So it's still about 2, but you need to make an inflection to make some agreement with the noun you're talking about. And then interestingly, when I did my analysis of Kinyarwanda, I found there were a lot of other inflection groups that do not match to the type of part of speech we are used to in English. So I call them others. So it's another inflection group. So for example, you have the word uti, ati. So you're saying umuntu yavuze ati, cyangwa navuze nti, cyangwa uravuze uti. So your ti, it's not a verb. It's none of these other categories, but it's inflectional. it has a meaning. It has something, some category in linguistics. So I said I'm not a linguist, and if they are linguists in this group, I'm sorry, I just call them others. But they probably has another. So it's a category that groups together all other inflection groups, all other productive categories that can generate inflections, but we don't have a very conventional way of calling those words. So it includes a lot of others, but I had to make it up. So for each of these part of speeches, you have to, so you need to know the lexicon, the list of stems and affixes, the morphotactics, how the morphemes are combined, the morphographemics, how the rules, how do you generate the final string after combining the morphemes, and then you need some custom filters for each of them. Okay, next, now the lexicon. So here I'm not talking about theory, I'm talking about the data that we have in the morphological analyzer. So the lexicon, so this table represents the lexicon, meaning the stems and the affixes that you have in a demonstrative pronoun. So here you have to list all types of morphemes and the slots that they occupy in a word. So I'm going to go through it and you'll see how they combine to make words. So this is demonstrative. You can start from like this word ng. So you can come from here and say nguyu. Let's say nguyu, nguriya. So that's it. I took it, it's not like a typical pronoun as we know, but it's some kind of plays a demonstrative role in Kinyarwanda. So you can have some nguyu, so you can have ng, then you add u, then you add u, and then you add another u. So nguyu. Of course, when you combine them, you are going to apply the morphographemic rules, which gives you the final string. But when you look at the lexical form, this is the actual lexicon for the demonstrative pronoun. So you can make different combinations. So you can have this one. So it's kind of hard to show it in a table like this, but basically anything that is demonstrative in Kinyarwanda can be constructed from this lexicon. So you can have a word like nha. So you can say nhawe, taking nha, then you, and then I think it's gonna take e. So hawe. So you're taking ha, you and e becomes way. So hawe, it's another kind of demonstrative. So this is very interesting. When you do the analysis, you see them coming out, and I think we'll do some exercise with that. But basically, when you do the lexicon, you have to analyze the data you have, and I came up with this table. It's probably longer than this. I think here there might be some other words for expressing classes, but basically this is what they are. So you need to name. So in the model that I have, you need to name the slots in which you have the morphemes. Okay, yeah. So that's lexicon for demonstratives. You can always capture it. And then I'm not going to show all of the tables because that will be too boring. I will do the exercise of running the actual morphological analysis, and you see them coming out live. So then this is a lexicon for the verbs. So it's a table expressing different pieces of information that can come in a verb. So you have you have an augment, you have a pre-init. Okay, because verbs are so interesting and so complex, I think I'm going to use a table that someone needs to mute their mic. Okay. So I'm going to give a table that gives examples of the morphology of Kinyarwanda verbs, and then you will see how all of these pieces of information become more interesting. So I'm going to share another document. So it's a paper that I wrote in 2020, that was published in 2020. So just a second. Okay. Okay. So you can see this. So, okay, it's a table that gives an analysis of these pieces of information that make up a Kinyarwanda verb. So the first one, the first slot, what I call the morpheme slot for Kinyarwanda, it's nominal augment. So these are, so augment is something in high school we called indomo. I'm not a linguist, but I think we call it indomo. So for example, you have the word, so here we're going to use a single word called gusoma. So a single verb gusoma, and we're going to see all of these, how these pieces of information come together. So this is for the analysis for wasomi. So this u, it's an augment that expresses, it's a determinant that expresses a person. So wasomi. Then you have these, what we call prefixes. So typically we have two for negation and then one imperative and one conditional. So let's start with the negative negation one. So himngasomi, right? Inhi, it's a morpheme that indicates that you are negating this verb. When you're talking about yourself, you don't say ninasomi, right? That's a rule you have to enforce in the analysis. So when you're talking about yourself, when you are the subject, so first person, you don't say ninasomi, you say sinasomi. So it's kind of two morphemes that express the same thing, but they have two different morphemes. They use two different ways depending on the case. So sinasomye cyangwa ntiyasomye ntimwasomye. So that's in ni. So that's the second slot. The third slot in the verb, or actually, you know, you don't put all of them at the same time. So when you do the morphotactics, you need to know how to transition from one to the other. So I'm also going to show the morphotactics model for the verb. Because the verb is the most complex, you have like 16 or actually it's 19 slots. So the second one, so the third one was the subjective marker, which usually has these morphemes for nouns. So these morphemes are actually related to the noun class system in Bantu languages. So so this is a subject indicator. So nasomye, vasomye, chasomye. So this first one is the subject indicator. Then the fourth slot, you have something that can be a negation called ta. So you can say kuko tutasom. So this ta is another slot that can come in between to make a negation. And then you have another slot that can express the tense, the aspect, or the modality of the verb, of the action you're talking about. So it has many morphemes. Each one of them has different meanings. Of course, they are talking about the tense or the aspect of, or the way in which this verb is expressed. So can have something like varasoma, bakazasoma, baracyasoma, and so on. So you can pick any of these and you put it in here and you get a different meaning, so expressing the tense. Then there is another morpheme in slot number 6 that expresses the emphasis. So wanasoma. Iyi na izamu hano, the na in between is an emphasis morpheme. So you can even read wanasoma. And then when you pass these prefixes, we get sometimes infixes or prefixes as well that are expressing objects. So in Kinyarwanda, when you talk about objects, we talk about verbs that are transitive. Transitive is a verb that has a subject. So, sorry, an object. So we can have like up to 3 objects in a sentence. So when you have 3, I use this object 3 as the 7th slot. So look at this. Arachihamusomera. So he read it for her while there. So yasomye igitabo agisomera umuntu, agisomera ahantu runaka. I can also give you another example. So you have the verb gushyira, to take something to someone. So I can give you a book. I said you send this, give this book to someone on my behalf. So you have 3 objects. You have me, who you are going to help. You're going to help me to take a book to someone else. You have me, you have the book, and you have the person you're going to send it to. So in that case, you have 3 objects. So if I tell you to take it to someone on my behalf, I'll say uchimunshirire. So you have u. Okay, u is the subject. Mu is the object, the person ugishiriye. And that comes in between. When you say uchimunshirire, there's a name in between. It's talking about me. So you're doing it on my behalf. You're taking it, and then you're taking the book. So uchimunshirire is another case where you have 3 objects in the same verb, in the same word. And then you, of course, you can have this 2 objects. You can have 1 object. So narakimusomeye. So you have chi, icyo gitabo, and mu, uwo muntu. So 2 objects. So I think it's called ditransitive. This case it's tritransitive. You have 3 objects, or you have a single object. So in this case you have arachinsomera, but it's still 2 objects, but the end is what we call object 1 in this case. So another slot is the reflexive slot, where you're talking about yourself. Self. So I call it I because of the morphographemic rules. So it's about self. So reflexive. So you can say yisomera gitabo. So this e is a reflexive thing that can be added in between. So it's not an object. It's kind of an object, but it's reflexive. And it's, when you analyze it, it can be separate from these 2, from these 3 other objects. And then at the end of the day, you have a stem. For stem, I don't know how many stems you have for verbs in Kinyarwanda, but it's something between 7 and 10,000. When you only consider inflection, not derivation. So this one in the table, we don't have it, but you need on the side. So when you're developing the morphological analyzer, you need to have a list of these fill-in words for the stem. So you need this list. And then you have some suffixes that express several things in Kinyarwanda. So example, kirasomeka, it expresses, so this expresses a lot of interesting linguistic phenomena. I'm not a linguist, but these suffixes are very interesting. So we can take different, we can see them coming up in the examples above. So this IR is yarachihamusomeye. So IR, I think it means you're doing something for someone else. Oh no, it means it means something else that is captured. So because I'm not a linguist and I didn't have the resources to name each of these morphemes as morphological features with very specific linguistic meaning, my model basically presents the morphemes as the actual features. So even though I name things here, each morpheme itself is a morphological feature. So I don't separate. I don't have. So in other languages, they do have what they call morphological tags. And when we're looking at the presentation from Professor Kemal, they had those tags saying like it's a verb, it's in a third person subject, it has this and that. So because Kinyarwanda is very complex, I didn't have it. I had to just use the morphemes themselves. One other interesting thing is that morphemes, even if they have the same string, they mean two different things. So, for example, these two in the prefix, you have ni. So when the word ends with e, it means imperative. Nimusome igitabo. So ni, it's kind of commanding someone to do something. This other ni, it's in the same slot, but it's totally different morphemes that has different meaning. This is conditional. It's meaning if. So nimusome, imperative. Nimusoma, it means conditional, if. So this means if, this is imperative. So so when you have morphemes, they are not just different because of their spelling, they are different because of the function they play. So that's why in some cases, when you have like this object, in some cases you might have this. So like in this case, you have the same morpheme with the same spelling, but having different meaning. So then at the end, we have other morphemes. I was going through the slots. So you have like a passive suffix, which expresses passivity. And then we have other, what are called aspect markers. So this slot is usually, it has some kind of correspondence with the 50 slot. So if you say aracyasoma, racha, usually these aspect. So if you have the tense modality morpheme being racha, it can mean that the ending prefix will be a. So there's a relationship between these two, which is kind of the concept of circumfixation, but it's more complex. So that's why this is also called aspect markers, and this is the tense aspect modality morpheme. So yeah. So like example, yasomaga. So aga also means it's in the past, and so the a here, which is this guy, it has to correspond to aga to make it a past tense. And then we also have something I called locational post suffix, which is yo homo. So yagezeyo, amukozeho, yavuyemo. So this is something that indicates some kind of location, things like that. So this is the list I wanted to show you just to show how complex Kinyarwanda verbs are. And when you do the analysis, you're gonna meet a lot of ambiguity, and so you need to disambiguate it. Okay, so let's go back to the presentation. Okay. So I was showing this lexicon and explaining these pieces. So we got a grasp of them, very complex. So now I have a model, a graph model of how do those morphemes, so these morphemes of the verb, how do they actually combine? And I made a graph model of how these morphemes can come together. So if you follow this graph, it has these five groups, and you need to go through every link to make a mingling. So it means, so initially you have three places where you can start. So you can start with this part where you have the prefixes, or you can start with the subject, or you can start with the object when you're doing when you're doing an imperative conjugation. And you have to end either in the aspect morpheme or in the location post-profit. So this graph shows how many combinations of these sorts can happen. And I don't remember exactly the number of those combinations, but they are in thousands of combinations. So so when you're doing morphological analysis of a verb, you need to go through these transitions. So here is a simple model of a morphotactics of a noun. So this is a card that is part of my database or my model file. So here I give the lexicon. Here I give representation of the morphotactics. So first you need to know which morphemes can you start from. So the starting morphemes. And here you need to know which morphemes you're gonna end up with at the end, which ones are the final states, final morphemes. And then you also have transitions. So which one can you come from to another one? So when you combine all of these, you will, so basically we are saving the starting state, the end state, and the transitions. So when you have this card like this, you can exactly form a graph model. So a graph model like this one. So when you're doing the analysis, you go through this and you will know exactly which words are allowed and which ones are not allowed. So example here, you have umwana. So it starts from an augment, you go to the class marker, and you go to the stem. Or you can start from the class and you transition to the stem. So vagavo. So if you're saying vagavo, you don't have a stem. You don't have an augment in the beginning, so you say vagavo. Or you have an augment, a class marker, a stem, and a suffix. Umuhindekas. Or you have just a stem. So meaning you start from the stem and you end at the stem without a transition, like it is zuva. So zuva is just a single morpheme. So it's just a stem without any affixes. Okay. Another part of the morphological analyzer is the morphographemic rules, which express which changes are made when two morphemes combine. And here I'm just giving a sample. It's a long list and compiled over some time, but I'm going to give you an example here. So here you have the lexical form, what we call in. So you have an input, and then you have an output. There is a conventional way of writing this in linguistics. But here, because it's a database, I just show the tables. So when you have key, a morpheme like a key, and you have a vowel that you're going to combine them, the ki becomes the cy, and the vowel stays the same. So this art sign means it stays the same. So, and these are some other information that the morphological analyzer uses, but I'm not going to talk about them because it would be just too complex. So essentially, you need to have all of these rules. You can pick another example. So when you have a with a vowel to the right, the a gets killed, and you keep the vowel. So for example, can I find an example? Let's say a noun. let's say a demonstrative pronoun. So you say awo, awoban, awo. So the class marker, so you can just go back to the, so you have the word awo, a, va, o, right? So this va and the o, when they combine, a is lost, a gets killed, and you have just bo. But when you analyze, it's going to be a, va, o. But when you spell it, it's going to be avo. So that was this rule that says a gets killed when the next character is a vowel and the next character becomes stays constant. So this is a table of morphographemic rules that are general, but you have to compile a lot of them through empirical experiments. And then you have the same thing for the suffix. So basically the tool will just, so you have this database that gives when this is on the left and this is on the right, then the output becomes this on the left and the output becomes this on the right. So these are the morphographemic rules that you need. Now we go to the filters. So filters are any other language-specific rules that you want to enforce. And for this, I had to develop a synthetic language that expresses different things. So what these rules mean, it's a long list of rules that the morphological analyzer uses. It means things that are possible and things that are impossible, right? So this language is not something we are familiar with, but I can interpret one of them, okay? So let's pick, okay, the one that's easier. So I have three parts for this matching language. So I have the part of speech or the inflection group. I have the morpheme slot, and then I have something that says what the morpheme is. So this means when you are given a morphological segmentation and it's a verb and it has the prefix C, it would require, so this match would require that the subject be the first person. So so you have, let me give you an example. I think we talked about this. So you have this negation, and this is actually a complement of the rule. So then when the prefix, the negation is in me, you can't have a subject being me. So let's say that case of yogusomigitao. So you can't say hinsomigitao. So it's hinsoma. So when it's the first person, you can't use in he. You can't say hinsoma igitao. So so you have to make this rule that when it's in he, you don't use when it's in he, you don't use the first person. But also when it is C, you only have to use the first person. So instead of hinsoma, you say sinsoma igitao. There are some cases where people violate the rules. Are we running out of time? Okay. So essentially what this means, you have to compile a list of rules and you have what the rules, when you have this, so it's kind of an if then kind of rule. So if this is matched, then this should be observed. And we have some other information here, like if you want to give weights or precedence weights to the rules, or whether the rule is required or is optional. So so we need rules like these for a given language to be able to create an effective morphological analyzer. Now we talk about the practical part, what I call the engineering practice, some of the things you observe. So because of these things you have to maintain, it's advised that you keep a model in a file. So you have like a database or a spreadsheet that has all of these rules and lexicon and morphographemics and so on. And then you need to use a language like the one I used here to express the rules. The other practical thing you need to do is to make sure that you have automated processing. So if you have this database of rules, you need to have an engine. So these are the algorithms that we talked about, the engine of the morphological analyzer that is going to process the model, that model, this model, all of these things are part of the model. So you need to have automated processing of those. And then because of the complexity, you need to do low-level programming. So like my morphological analyzer is developed in C with a few things in C++, but basically low-level so that the things become fast. You need to do parallel computing. These computations, I mean, they take processing time. So you have to take advantage of multi-core architectures, multi-threaded programming, using things like multi-threads, like pthreads or OpenMP, things like that. And you also have to do caching whenever possible. So if there are some computations that are very regular, you can save them. You can save the outputs and then reuse them. This means caching in memory. So, like, for example, if you're processing a string and you get an output, and let's say you're analyzing a document or a list of documents, and that word is going to come more often. So you don't have to run the morphological analyzer every time you meet it. But once you meet it once, you get the output, you save it, and then next time you meet it, you just do a simple table lookup, and you get the same output. So these are some of the practical aspects of implementation that someone has to use. Okay, so this is an example of, not an example, this is a specification of the language I was talking about here. So this language that expresses the if-then condition at the level of morphology, they actually come from a language that I had to develop that has parts of expressing regular expressions, expressing distances between morphemes or distances between words in a sentence, or combining multiple rules by some kind of and or and some other things. You don't need to care about this, but it's just that I had to develop this language so that I can express all sorts of things that the morphological analyzer will need. Okay. Next, I want to talk about the morphological disambiguation, but I want to check first if there are some questions in the comments before we go to that next section. Okay, so first question, how did you approach the numerals? So the model is consistent. So the numerals, they are also another inflection groups. So you have to present the same kind of things. So you need to have a table of the lexicon. You need to have a table of the morphology. So a morphotactics card like this one, where you present the states and the transitions. And you also need to have the prefix and postfix rules. Prefix and suffix rules. And also you have to filter. So you have to model all of the numbers basically with exceptions. For example, when you have kabiri, right? And you want to say 2 cows. You say inha ebjid. So you have to use a. But when you want to say 2 let's say two animals, you say ibisimba bibiri, inka ebyiri. So when you do the morphological analysis, you need to come back to the stem being number 2, so you have 2. But when you do the surface form realization, you need to do that exception and mark and mark those exceptions. So another question. So did you use the morphological tags? I didn't use morphological tags. I just used morphemes themselves because I didn't have, there was no standard that I could use immediately. But there is a standard called I think it's called the unimorph or universal morphology, where they define tags. And in the future, maybe someone can map it to the universal morphological tags. But for now, we just use the affixes. And even if affixes have the same spelling, like the example of ni, you have to keep them separate. So did you store the imperative or infinitive form? No, I saw just the stem. So so infinitive, it's just another type of inflection, but I store the stem. So if you have a verb like kugenda, so I just store gend, so G-E-N-D without a at the end. And then when I combine, I have to add, and so on. Is it also possible to release the data set for analysis by linguists? I don't know how to answer this. Maybe we can talk it offline because it is not exactly related to the subject matter. Okay, given a word to analyze, do you break it down into smaller pieces? If so, how do you determine the common denominator for breaking? So so that's the main part. So I go through the graph. So it's kind of a state machine. So if I meet something, I want to parse it as a verb, I first need to know if there's a prefix that match a nominal augment. If it is, I strip it out, and then I keep on stripping off all of the pieces until the end. So that's the engine. I'm not talking about it, but it's obviously going through the graph and then picking out pieces, picking out prefixes until you remain with the stem. Okay. Okay, so I think we can go next to the morphological disambiguation problem. So here is an example of analysis. You have something like mpuzamwibeshyeho. When you analyze it, you have to look through all of the combinations of affixes that match the morphographemic rules. You find a long list, and you need to choose from each of these segmentations which one is right, which one is correct. And this is a hard problem. So in this analysis, so you have these 19 slots for the verb. Actually, I think they're okay. So you have these slots and you fill in the morphemes, but they are all different. So if each combination is different, it's adding or combining things in a different way. So, but when you look at the same stem, you might have things that are also ambiguous. You might think the stem is kwibesha, kwibesha, or it is kubesha or kubesha, things like that. So how do you solve this problem of disambiguation? Because if you need to narrow down to a single segmentation, you need to choose one. So which one do you choose? So basically, this is usually done through statistical approaches, machine learning. But the challenge is, if you're using traditional machine learning, where you hope that someone is going to provide you with examples of parses, so if they give you like a word and a parse that's exact, it's kind of challenging because you can't get a big data set enough, because someone to be able to do this, they need to be a linguist. So it's very hard to come up with a huge data set for statistical approaches to be effective. So is there a way to be more efficient? So the solution to this is my paper I wrote about morphological disambiguation through stemming. So we try to do the next best option because we don't have a lot of analysis segmentations that we can train a machine learning model on. So I rather recurred to using inflection stem pairs. So you give people a simple interface where they can see a word and inflection. So you have a word that is a conjugation, an inflection of some stem, and then you ask the people to choose which one is the right one. And then the goal is to be able to use this information, this data set, to learn a way to disambiguate the segmentations. So, for example, you have a word in nzigire. It means something nzigire, cyangwa nzigire, cyangwa nzigire. So it may have different stems. It may have a stem from about kwiga, or kugira, or kwigira, or kuziga, or kujya. So these are all possible cases. So it's challenging, but we can do some kind of voting. So we can ask users to pick which one is right. And then at the end of the day, we get a data set that is an inflection and stem pair. So you have an inflections like this, irabyishimiye, and the people, the data collection people, they have indicated that it's most probably kwishima, although it might have some aspects of others. But when you collect a big data set, you end up with probabilities. So what's the probability of this word having this stem? So to be able to do that, we need to design a classifier, or at least something that gives probability to stems, which can be used for disambiguation. So these are some details of the paper. Because we somehow exceeded the time, I don't want to go into all of them, but whoever is interested can read the paper. But basically, the idea is simple. When you get a data set like this, stem inflection pair, and people have contributed data like this, you end up with things that has higher probability and things that have lower probability. So the idea is to be able to know the features of this word, and based on these features of the word, you give probability to one of the stems. And when you are doing disambiguation here, you disambiguate based on the features. So you take the features. So the features of each segmentation, you put it into the classifier, and the classifier is going to give you a probability or a score or something. So for example, this one is very ambiguous. Like the one on the top, it's very, very probable. So actually, it's sorted by the probability that's assigned by the morphological analyzer. So for example, this one means me, a negation, u, meaning you, za, meaning in the future, mu, meaning the subject, sorry, the object, ibesha, so kwibesha, to err, to make a mistake, e as the aspect, I mean the prefix, the suffix, and then ho as a location, or I mean ho can mean different things. So this means it means don't lie to yourself. You should never lie to yourself about someone. So this is the one that has high probability. But you can see, so if you see the probabilities, you see that there are some that are very ambiguous. and some of them that are less probable. So the model takes this segmentation, it gets the features of it, it puts it into a classifier, and then it assigns the probability. So how does the classifier work? I'll talk more about the features, but the idea is to, when you get the data set, so a data set like this, so for the things that people have said are the most probable, you give the probability of 1 over n. So if you have 5 valid segmentations that have the same stem, you give them the probability of 1 over n. And for others, you give them probability of 0. So now you have a traditional classification problem where you have input being a vector of features and the output being a probability. And you optimize a cross entropy loss function. So I was using like a neural network. So neural network is just one form of a classifier you can use to solve this problem, and this is called the cross entropy error. So which basically tries to lower the error of giving the features you predict the probability. And the main contribution in this paper was to design which features to use. So I don't know how much time people have, but because this is going to be covered just today, I'll just go through this. So how do you get the features? So there are 2 types of features that are in this paper. There are those that are called similarity features. So similarity features means, so let's say you have this word that it's given it to annotators. You have gatwikiru. So it can have multiple meanings. It can mean quicker. I mean, the lemma can be quicker, to sink or follow drop. It can mean guchira, less probable, but it's if you pass it through the morphological analyzer only, it's gonna give you this as another potential stem, or gutwika, to burn, or gutwikirwa, to be covered, or gutwikira, which is actually the stem for gutwikirwa, but the analyzer might give you both options. So you have these, and how do you generate features for this, for every segmentation? So the one set of feature is the similarity features. So you take the word, this word gatwikirwa, you try to see how similar is it to other inflections of kwika. So you compile a list of inflections of the verb kwika, and then you try to measure the similarity score between this verb gatwikirwa with these inflections. So if the stem is ik, it might be still very similar to these inflections. If it is about gutwika, it may be closer to this inflection group. So how do you measure the similarity? So in the paper, we talk about similarity based on word embeddings and similarity based on corpus statistics. So basically meaning, is it as frequent as these inflection group, or is it is it as frequent as this other inflection group? So you measure a score, which are some equations that we put in the paper, which expresses the similarity between the input and other inflections in the same target group. So you get these as features, and you also count this. You measure the similarity based on the frequencies of the word in a corpus. And then there are also those we call indicator features. So indicator features means the morphological features that are in the word. Yes, is that?
Yes, Antoine. Thank you so much. I just wanted to, point to our time because I think at the moment it's
Okay.
6 p.m. cat in Rwanda.
Oh, okay. Okay. So what I'm gonna do, I'm gonna ask Isaac to share the slides with you guys. And so this is very deep. And then I point you to a tutorial where you can test these tools. So here we're going to talk mainly about the disambiguation. And after disambiguation, I was pointing you to the tutorial where you can test this morphological analysis tool. And for the people interested, there are two papers that talk about these two subjects. One is the disambiguation without a context, and the other one is disambiguation with context. So the main finding of this non-contextual disambiguation is that the indicator. So if you get the indicator features for the segmentations, and you use them as you take summary statistics of them, you get very high accuracy. So that's something that people interested more into the subject can look through the paper. So the other part of disambiguation is when you're given a context. So in this case, you use some linguistic intuitions like syntactic agreements. So if you have a word like abagabo, bafite, you have that tuba that repeats, which is a syntactic agreement, and you will use this kind of agreements to form a morphological, to form a probabilistic model about the disambiguation. So this is in the second other paper. I should send the link, the link of this. I mean, if you look up through Google Scholar, you can find these two papers and you can find out more about it. So this is a probabilistic model for part of speech tagging that uses the contextual information to do the disambiguation. So I'm not gonna go through these questions. I just wanna go straight to, okay, I don't have a lot of content on the language generation. So there's another paper that's coming out soon that's going to talk about the algorithm for generation. But essentially what it is that when you have applications like machine translation or summarization or dialogue systems, chatbots, and you are generating a language data, you need, and it's Kinyarwanda, you need to make sure that you generate inflections that are plausible. So typically when you do like a language model or a translation system, the output is a probability table that gives you the probability of different, so in case you are predicting the morphology, it gives you a probability of different stems and affixes. And so how do you decode that into the actual word? And so this is the problem of morphological inference or decoding. And then when you decode the probability vector into affixes and stem, you still need to use the morphological synthesizer to be able to combine the morphemes to form words. So, for example, so you have this analysis N, Ra, B, Ang, Ye. So this means I just want to express it. So this means I am the subject, me. Ra, it means it's a kind of tense that's in Kinyarwanda, and V is the object, something. Ang is kwanga, the stem, and then Ye is the suffix. So you need to use the morphological synthesizer to use the morphographemic rules in reverse to form the final surface form. So you have this lexical form, you convert them into ndabyanze, which is the final thing you output. So so this is the morphological generation. It's kind of the most interesting part is the decoding of the probability vectors, but we don't have time to cover that. So I will go straight to the repository where we have this toolkit for natural language processing of Kinyarwanda. So I'm not sure if people want we go through this together or you go and do it yourself. So let me. Okay, this is it. Okay, so okay, so I was going to point you to this GitHub repository where we have these tools. So let me share the link in the chat box. So this is the toolkit that does deep learning for Kinyarwanda NLP. And I also want to point you to the papers. So this is the paper about morphological disambiguation.
Antoine, I believe
Yes.
you're sending me the links. You're not
Oh.
sending them to the full chat. Yeah.
Oh, sorry. Yeah, sorry. Okay. So this is the NLP toolkit that points you to the morphological analyzer and the deep learning toolkit for Kinyarwanda. And so I'm also going to share these two papers. So this is the morphological disambiguation without context. And this paper, even though it talks about language model, it has a section on contextual disambiguation, that probabilistic model is showing. So, these are the links. Okay. Okay, so this is a toolkit that we open sourced to do different natural language processing tasks for Kinyarwanda. And it's based on the morphological analyzer. It's based on the morphological analyzer and PyTorch framework. So it has high system requirements to store it. So currently it's only possible to run it on Linux. And because of the data sets that we use that are very huge, especially like probabilistic tables and word embeddings for such a complex morphology, it has a high system memory requirement. So usually this is something you run like on a professional workstation or a server. So it requires like 45 storage space and 40 gigabytes of memory. And these are the steps for downloading the morphological analyzer. It's posted on a Google Drive, but it's a huge file. So if you want to download it on a server, I give the instructions on how to do it. I think Kleber has gone through this process, and he can help some people who are interested in doing that. So these are like the commands that you need to run to have the morphological analyzer running. One thing I can do, I can run it from my machine and just to show you how it looks like from the terminal. Let me launch it. Okay, I don't think they have much time for that. Okay, so you can go through this tutorial. It requires some Python experience to understand it if you want to go deep into the code, but you can also run it without dealing with the code. And it has several, so that's the morphological part. It has two examples of running it. And then there's a free license for using the morphological analyzer, but it's only for academic and non-commercial purposes. So you can request the license, and when you run it, you provide it to the command line. And then you can download this toolkit. So there are two parts. So you have this library called morphological, which is basically the morphological analyzer and generator. And then you have a Python package called deepkin, which is in this repository, which you can use to do some deep learning models and neural network stuff in PyTorch. So this is the steps on installing the toolkit. And then these are examples of models you can run. You can do named entity recognition, where you give a sentence or a document, and it's going to tell you the different entities that are in it. We have text classification and natural language inference tasks for a model called Kinyarwanda, which is part of that paper I was pointing to. We also have generative pre-trained transformers, GPT, autoregressive language models, which you can try as well. You run it and then you give it text and try to do auto-completion. So it's an autoregressive language model you can look at. Okay. So, okay, this is again for named entity recognition. Yeah, so you can go through this tutorial on your own. If you face issues, I think you can create issues. You can post issues on this GitHub repository, and you will be able to address them. I don't think you can go through all of these together, but it's not hard. You just need to be familiar with the Linux basic commands, and then install the tools and run it on your own. So I think that's it. We don't have much time to go through it together, but I don't know if Kleber or Isaac has a final word just to conclude, or if people have other questions that I can answer.
Yeah, thank you so much, Antoine. This was a very insightful session, a very exciting and in-depth first one, and I really think it sets the bar quite high for what the audience is to expect in the coming future. And definitely, I think what we've done in this closing is give you, the audience, a sneak peek. Well, not a sneak peek, but a preview of this larger library. But I think we'll have opportunities to delve farther into the other language models together with Antoine in the coming weeks. We are working to make this consistent, so weekly. And yes, and Antoine is also eager to connect, and Kleber as well as our man here on ground. So, if we have questions, we can also ping him. Regarding the morphological installation, Kleber and I have been working on it, and we're looking how to eventually make that available, perhaps even remotely over a server. But I also do know that Antoine is helping us to work on a blog that can help you work through the steps of how to install it and maybe troubleshoot some general issues. So yeah, I think this was a very first in-depth, theoretical presentation. And now, as you see that the essence of the community we're trying to build here is open source, you can now go find these toolkits online. So I want to again thank Antoine so much for your time. Antoine, thank you. But even most importantly, I want to thank everyone in the audience here today. All 20 of you, all 20 plus. I know we lost some halfway through, But thank you so much. It's a Saturday and we know it's evening hours, but you made your time to come here and yeah, and be together with us in pushing natural language processing for Kinyarwanda further. I also hope our other community members from other various languages, other regions, can also have some take home and could also influence us in the coming lectures in the coming future to say, you know, maybe this is how this adapts to my language or my use case context. In wrapping, I believe that Kleber has also been helping me to work on a survey. So we would ask you kindly to take a moment of your time before jumping out of this this call and answer our survey that Kleber just dropped in. And this will enable us to understand how well, you know, you digested this lecture and what kind of content we can maybe improve or the format in the future. Thank you so much, Antoine. Thank you, Kleber, for moderating in the background. And a big applause for the audience for being here with us today. Have a nice evening, everyone.
All right. Thank you, Isaac. Thanks, everyone, for coming.
Yeah, thank you.